Welcome to automationgenie.com. Today we are going to demonstrate the application we have developed it, that is called as a tag. It translates the TCL code into Python, and TCL being used across many companies like Juniper, Cisco, Intel and many others you can name. And it has today we developed a TCL set of scripts to configure OSPF on Cisco routers. Here we have used Cisco routers 1900 series routers. So in this topology we have three routers. They are connected by gigabit Ethernet and fast Ethernet one connection, and gigabit Ethernet and gigabit Ethernet in another connection. In this topology we are going to configure OSPF. We are going to create a set of networks and enable the OSPF on all of them. So the OSPF these routers land the OSPF routes, and they should be able to reach each other. So generator should be able to reach a reflector, and reflector should be able to reach a generator. Similarly, the UUT will be distributing the routes. It is landing from a reference and generator as well. So I will show the TCL scripts here, which we have developed it. So in this one we have a set of scripts. The config.tcl contains information about the Cisco routers, and the router setup contains information how to reach to how to configure the routers, like enabling login to the router, and ping routine, configuration of routines and unconfiguration of the routers. And the basic configuration contains, as soon as the router boots up, what is the minimal required configuration is put into this TCL script. And the automatic test contains the suit line kind of thing, and the actual OSPF configuration happens in the OSPF test. So these are the scripts we have written, and I'm going to do the translation of them. I'll show the demonstration. So this command line translates all the scripts, all the TCL scripts into the Python. I'm going to pause a while. Welcome back. Here the translation has just finished it, and let us go over the changes. Let us run the whole general TCL things, how it configures, and we will see that. So yes, okay. It logs into each of their routers, and then it configures the basic, it gets the show version information on all three routers, and it configures OSPF on all three routers, UUT, generator and reflector. You can see here the router OSPF is being configured here in the TCL. This is all OSPF configuration running over here. Now next it verifies the OSPF routes land. So what it does is it goes to each of the routers, reflector, generator and UUT, and understand and sees what is land via OSPF. As we are focusing on OSPF only, so the script only checks for the OSPF routes and using regular expressions, and and it checks on all three routers. Because the OSPF process is running on all three routers, we are verifying in all three routers. Next it does it ping test from generator to the reflector, and reflector to the generator, and similarly generator UUT to the generator and UUT to the reflector. we do all the so this is being verified now in the TCL. Now I run the converted Python scripts. The name will be TCL name changed to the automatic test used to be there .tcl. Now it is changed to the automatic test.py. It does the same things. Gets the version information, then again configures the routers with OSPF, collects the route information, and finds the whether the network is there. So till here it is the TCL. Now here is the Python. From here we started running Python. The same script translated one we are running. Here it is spanning to the routers, 3 routers, and then again it goes and configures the first initial basic required configuration like terminal length 0 and some loopback interface. Then it configures the OSPF as you can see here, and it is a UUT it is being configured. Then generator, then reflector, then collects the route information. So and it validates what are all the routes it finds. Then again it validates what routes it is find via OSPF. Then it does the ping verification. You can see here the ping from from UUT to the 35001. It is reflecting to the reflector sort of thing. UUT to the reflector, generate ping to generator from UUT. All variations we do the ping testing on this to make sure that the routes are land and their routes are land and able to ping via the OSPF land routes. Let us compare now the translated code and original code. This is the initial thing, and so that original code is having sourcing of the OSPF test, and it has contained the topology. The topology is same as you can see here, G01 FA0100101, and same thing is being used here for the topology. And these are our libraries which contains TCL simulated code, like your code will be interacting with the TCL as if you are talking to the TCL, but underlying our libraries take care of the modifying the TCL lists, TCL structures as such. And next down one is the original code and top one is the converted translated code. So the translated code on the right side, translated code on the right side and original code on the left side. As you can see here, from RTRs in TCL it is sourcing it. It is translated into the Python as from keywords, and similarly the original code is like this, and the translated code is converted into TCL list, our own library code. This is about the basic configuration. This is this config.tcl contains about information about routers, like what is the IP address of that and what connection we need to establish, and what is the password to use. And if it is SSH, we are going to use PEM file. And if it is image and CSR, all the information about the router we kept it here. And similarly, the translated code contains exactly the same information. So here we go over the procedures. First contains the spanning router, like connecting to the router. So it contains a set of you make the telnet connection to that, and initially the router prompts with a password. Similarly, we enter the password, and we expect what is expected. So the similar translated code is here. Next, we print the headline, and similarly, yes, this function I am not using it. Let us skip over this. Next, configure routers is being used. So whatever the command set of configurations you have passed into this, right, those will be executed. So the RTR name, it is not the original name that we passed it, the name like RTR1 or 2 or 3. Here we have an internal mapping like generator, reflector and UUT. So the RTR name will contain what is being, are you configuring on generator, are you configuring on UUT, are you configuring on reflector. So we have completely what the suite line contains. The router name need not be put. So these scripts can be run for any other set of 3 routers. So if I just change the suite line, then automatically it runs onto the new set of routers. So there is a mapping internally happened. It is taken care by the setup code in the router maps. Now the ping command, similarly. From router contains, are you pinging from generator, reflector or UUT? That is contained in the from router. And what is the destination you want to do? These are the set of IP addresses that you want to pass it. And similarly here we are running the OSPF routes. We are verifying the OSPF routes. This is the function for the same exactly equivalent of it. Next, set RTR consoles. This RTR consoles will call the span process, which I mentioned in the top, right? So it goes over all the 3 configured routers, and it calls the span router, which I mentioned in the first, which is a first function in the file. And since this gets router span ID, so the script will call for UUT what is the get the span ID, like connection ID. So it doesn't know what is being passed in the suite file. It only knows about generator, reflector and UUT. The user will have understanding of router 1, router 2, router 3 with his own names, but as the script maps into the relevant names. The script even calling when he's making a call, he uses the logical topology here. He remembers, the script author will be remembering only generator, UUT and reflector. He doesn't care about what is being referred in the suite name. So that's all about this translated code. So here is the actual OSPF configuration happens here. This router setup earlier file router setup contains a generic routines which can be used by any script. Like if now I'm showing about OSPF. So tomorrow BGP being developed, BGP test cases are written, then they can use the then they can use the routines made in the router setup, which I. So these are generic routines. So I put a layering as well. This utility functions I put it into the router setup. So this router setup being used by across all the scripts like BGP, OSPF, or tomorrow any other new functionality getting added. All the utility functions are written into the setup itself. So the functionality OSPF specific things are written into the OSPF test TCL. The OSPF awareness is not there in the utility functions. So lib send and expect is again OSPF things. I think, yeah, this can be moved into the utility function as well. Okay. Here onwards, enable OSPF on interface. So here basic routers like first it will take whatever being interface passed, it will enable the OSPF area 0 configuration being done on that. Similarly, OSPF test, this is the core routine of all of that. It does actually it runs many tests like configuring routes and verifying the routes, and then the ping to the routers. All these being done here in this. So here on the generator we want to run these set of commands. Okay. On the UET we want to run these set of commands. So we will this commands passed as it is, and when we configure router with these commands we passed it, we are calling this utility function that on UET these set of commands to be running. So that is what we did it, and it will automatically configure them there. Similarly, on the generator, these commands to be run, and we pass the generator the commands. Translated code also has the same things. And configure router, we say that we instruct the script to do configuration of the generator with the generator command. Similarly, reflector. And now we want to verification portion. So I said that UET networks are these ones. UET networks are this one, and generator networks are these ones. So these networks are land on the reflector. We are verifying it here in this place. And what is the next hop should be there? It should be on the UET's reflector connecting interface, which is these routes, all these routes 34 up to 21 to 34 and 25 to 29 should be land via 30.30.30.31. So that verification is being done here. Similarly, the same process gets repeated onto the generator, and same thing happens on the reflector as well. So the translated code contains exactly the same. As we have run the translated code also onto the routers, and it also run successfully. Yeah, that's it about the demo. Thank you for watching.